spent the last couple days talking about the multiplication rule for compound events. Multiplication rule means I want two things to happen at the same time. I want this and this to occur. I want the pirate to hit the captain. I want the captain to hit the pirate. I want this and this to happen at the same time. So we multiply them. Now, the addition rule, we've changed it from and to or. I want either this or this to occur. I want this or this to happen at the same time. So we're going to add or combine the different probabilities from those separate events together. But how do I combine them? That's going to be determined by what type of events they are. Just like I have independent and dependent events, I have what are called mutually exclusive and overlapping events. Mutually exclusive events are two different events that cannot occur at the same time. The Venn diagram for that is down below. I have two events, A and B. Is there anything shared between those two? Do those two circles intersect at all? There is no overlap. Nothing in A is in circle B. Nothing in A is in circle B. How about an example of that, perhaps? I roll two dice, I take the sum. Could you roll a 5 or a 6 at the same time? Could I roll a 5 and a 6 at the same time? Is that possible? Wait a second, could you roll a 5 or a 6 at the same time? Okay, I rolled two dice, I take the sum. Is there a way to roll a dice and get a sum of 5 and a sum of 6 at the same time? No, it can't happen, right? They either have to add up the 5 or they add up the 6. How can they do the same thing at the same time? I can't. So I'm talking about finding the probability of rolling either a 5 or a 6. I'm going to use this rule on the board to add those probabilities together. The probability of event A or event B, this U symbol here, is short for union. Basically means or. What's one or the other? To find the probability of A or B happening at the same time, I take the probability of A and the probability of B, and I add them both together. Let's go back to that 5 or 6. Molly, how many 5s are there? How many ways are there to roll a 5? 4. How many ways are there to roll 6? So if I want to roll a 5 or a 6, can that happen 11 different ways? The 6 ways, the 5 ways to roll a 6, the 4 ways to roll a 5, 6, well, that's 9. That's 9 different ways, right? Can't I roll a 6 or a 5 9 different ways? I added them together. How about overlapping events? Overlapping events are just the opposite of mutually exclusive. There are two events that can occur at the same time. There are shared outcomes between the two. There's a way to do both at the same time. Here's the Venn diagram for overlapping events. How is it different from the ones above, Kira? Again, they're overlapping, right? They touch each other, they intersect. Is there a way to do both A and B at the same time? That's why they intersect with each other. So when I combine overlapping events, I have to be careful not to double count anything. I want to find the probability of what's in A or B at the same time. So I'm going to count up everything in circle A. I'm going to count up everything in circle A. I'm going to count up everything in circle B, because it could also be event B. Emma, did anything get circled twice? Say again. Oh. Did I circle through anything twice?
Oh, yeah.
Right here, right? Didn't I count this when I counted up everything in circle A? And I counted it again when I counted up everything in circle B? I don't want to double count anything, so I have to add up everything in the first event, everything in the second event, but then subtract off What's in A and B at the same time? Subtract off the overlap, in other words. Back to mutually exclusive events, I don't have to subtract off the overlap because they don't overlap. When they do, I need to subtract off the overlap because I don't want to double count anything. We did an example with the mutually exclusive events of rolling a sum of 5 or a sum of 6. There's 9 different ways to do that. They can't happen at the same time. Let me give you a different scenario. I want to draw a card and find the probability of selecting either a king or a spade. Tell me how many kings are there?
4.
Okay. I'm going to underline the 4 kings. Okay. I can select either a king or a spade. So let's add that with all the different spades that are possible. Cal, how many spades are there in that? 13. I'm going to box in all the spades. There's 4 cards that are king. There's 13 cards that are spades. So does that mean that there's 17 cards that are either king or spade? Why not? Yeah, did I double count something? Yeah. I counted up the king of spades when I counted up the kings. I counted up the same king of spades when I counted up all the spades. I need to subtract off the overlap. What's in both? What's a king and a spade at the same time? I'm using that addition rule formula to find that total of 16. There's 16 different cards that are either kings or spades. What questions do you guys have here so far? All right. If there's nothing, let's try this first example with what's behind Bethany and Emma on the other board, please. When I first read through some of these practice questions, I think it's good to identify whether they're mutually exclusive or not first, and then draw some sort of table or diagram to get started. We'll do the same thing here. So the scenario is this. 500 students are in a high school, 300 of which wear a necklace, 200 of the students wear a ring, and 125 wear both. We're going to pick a high school student at random. Let's first make sure we know what's going on. Sylvia, are wearing a ring and a necklace mutually exclusive? Can you do both? Yeah. So are they mutually exclusive? No. They're overlapping, aren't they? Because there are some students that wear a necklace. There are some students that wear a ring. In fact, how many wear both? We're told that, aren't we? 125. No. They are overlapping. Back to 125. Do both. Let's draw a Venn diagram similar to what's on the other board. Which Venn diagram are we going to draw? What do you say, Molly? You're right there. We're going to draw a Venn diagram with 2 separate circles like on top, or 2 circles that intersect like on bottom. Why?
Because. Oh wait, for number 2.
Well, let's just draw the Venn diagram for the whole scenario. Can you wear a ring and a necklace at the same time?
Yes.
So shouldn't the circles overlap each other? Because some do both? Okay. So I'm going to draw a Venn diagram. I got a ring. I got a necklace. Here's the overlap. This part of the Venn diagram represents the students that do both, right? They wear a ring and a necklace. How many are there, Bethany, that do both? How many students wear both a ring and a necklace?
200 and...
It should say it.
Where's the...
125 do both?
Oh.
We're going to put some values inside this Venn diagram to help us answer some of these different probability questions. Zoe, how many students wear a ring?
200.
200. All right, so in the ring circle, 200. Anyone spot my mistake? Here's something everyone does every year I teach this, even in my stats class. What mistake did I just make? I counted what? So I counted up those that do both twice, because I've counted them once here, and I put the 125 here. Didn't I count them again when I put the 200 here? This 200 includes the 125 that do both. How many students just wear a ring? A ring but not a necklace? 75. That's what goes here. Isn't this part of the Venn diagram? Those that wear a ring but not a necklace? If 125 do both, and I know 200 in total wear a ring, does that leave 75 over that just wear a ring but not a necklace? What should these two add up to?
200.
Do that? Yeah, that makes sense. Nice little way to spot check there. Okay. How about next? Cameron, what's going to go here? How many students just wear a necklace and not the ring? 175? How are you getting that number? Okay, so you're saying 300 wear a necklace. So what's in the necklace circle? What's in the necklace circle of the Venn diagram has to make a total of 300. I've already got 125 placed in the overlap, so there's 175 left over for here. Okay. Let's check this here. How many students were surveyed, Tam? Add up those three numbers. Those three numbers in red, they make 500. Shouldn't the entire Venn diagram have all 500 students in it? Do I? How many have I accounted for so far? 375. Where are the other 125 students?
Not wearing.
Say that thing. Sorry.
Not wearing a ring.
So there's 125 students that do neither. Where can I put them?
They don't go in the diagram.
What's that?
They don't go in the diagram.
I can put them somewhere. They're just not going to go inside any of the two circles, are they? There's 125 students that wear neither a ring nor a necklace, so they can't be in either one of these two circles.
Wait, how does that make sense? Because it says 300 are wearing a necklace and 200 are wearing rings. So that's 500 and then 125.
Okay. When you add up 300 and 200, double counting 125. When you add up the 300 and 200, you're counting up the 125 twice. Right? Let me show you why here, Emma. Aren't there 200 that wear a ring? And 300 that wear a necklace, right? Who got circled more than once? So I can't double count. All right, let's do some probabilities. The probability of wearing a necklace but not a ring. What do you say, Zoe? How many students wear a necklace but no ring? Venn diagram. Which of those four numbers is 170? Necklace but no ring, 175. Out of 500, that reduces down to 7 and 20. A necklace or a ring or both. Necklace, ring, or both. Kara, how many students wear just the ring? Okay. Just the ring, that's the 75. How about just the necklace? What's that, Kara? Okay. How about both? How many students did I just underline? Add them all up. How many students did I just account for? 375. About 500. Is that reduced down to 3/4? I divided by 25 to get 15 of 20, which is just 3/4. Destiny, you got the tough one here. Here's the tough one, Destiny. How many students don't wear a ring? How many students do not wear a ring? That's the next question. I want to find the probability of not wearing a ring. That's those that wear neither. Okay, let's try this, Destiny. How many students do wear a ring? How many students do wear a ring?
Oh, 200.
200. So how many students don't wear a ring? If 200 do and there's 500 total, how many don't?
300.
300. Now, how can I get to 300? By looking at the Venn diagram. If you don't wear a ring, that means you can't be either one of those two values. You can either wear just a necklace or nothing at all. What do these two numbers add up to?
300.
Is that just the same 300 that Destiny said? Easy to reduce, 3/5. Wearing neither a necklace nor a ring. How many, Emma? Necklace nor ring. Neither necklace nor ring. Nothing, right? Don't wear a necklace, don't wear a ring, they don't wear any jewelry. That's the 125 here. Yep. Questions here? Okay. Let's look at the next one over on the other board. I'll stop this here and give you guys a second to try this.